So thank you all for attending. So that we're already like 200, more than 200 invites. So thank you all for being here. Actually, I'm located in Argentina, but working for Sao Paulo. So we're really spread all over the world: Berlin, Sao Paulo, San Francisco, Buenos Aires, Mexico. So I'm a data science manager, joined Nubank 2 years ago. Now I'm transitioning into a GM role. So go data science leaders. And I'm here with Cinthia to talk about what we think that machine learning models, useful machine learning models are. Like this, it's very similar to what Jacob said, but from a different standpoint. And we try to bring examples directly from the customer support, which is the area in which we both work.
Hi everyone, I'm Cinthia. I'm a data scientist. Also in a transition, but in my case to product management. I work in the CX team at Nubank with Matias, and I'm also super excited to be here. So starting our presentation, as Matias said, today we're going to talk about what are useful machine learning models. And as a teaser to what comes next, I would like us to remember about the Netflix prize competition that started in 2006. In this competition, Netflix offered a prize of $1 million to the team who could improve 10 percentage points in one specific accuracy metrics for a given data set. And then after 2 years of competition, there was this team called Belker's Pragmatic Chaos that won the prize by improving the metric by 10.06 percentage points. But then moving fast forward in a blog post from 2012, Netflix revealed that they never used this algorithm. And then this may sound shocking given that in general, you have like accuracy metrics and these are what guides the conception and the development of machine learning models. But in the case of Netflix, their team decided not to use the algorithm because of the engineering costs that were too high and because of a change in the direction of the product, since they were moving the business from DVDs to becoming a streaming service. And then they were pursuing personalization at the user level at the time. And then their blog post goes on describing how recommendations are core to the experience that Netflix provides and shows good examples of features that were designed for the user, for example, bringing explanations along with their recommendations. And their conclusion was that now it is clear that the Netflix prize objective accurate prediction of a movie's rating is just one of the many components of an effective recommendation system that optimizes our members' enjoyment. So recognizing that model metrics are only one part of the components of an effective machine learning product, we would like to bring a reflection on how to design useful machine learning products. So today we'll like to talk about why is it difficult to design for machine learning, when to use machine learning, and also have a deep dive on fascinating examples from customer support at Nubank. So if we want to build useful machine learning products, we first need to be able to distinguish them from other digital non-machine learning products. And this requires to think, why is it difficult to design machine learning products? And then to explain it, I will bring an example of a coupon recommender system from Target, a popular general merchandise retailer in the US. And just a disclaimer about this story, there's been some controversy whether this anecdote we'll bring here is true or not. But we'll use it here just for the sake of showing the uniqueness of machine learning products. So almost 10 years ago, there was some buzz about an algorithm for predicting pregnancy likelihood. It was used to send coupons for baby items. The algorithm was based on purchasing behavior of people who signed up for Target baby registers in the past. And there was this anecdote of a father who found out that his daughter was pregnant because of that. And then in this case, what you see is that because the algorithm is using a lot of purchasing behavior data, it is capturing patterns that humans might not be aware of or at a surface level wouldn't even make sense. And then after seeing the daughter had received coupons for baby items in her email, the father reached the Target store and then he managed to speak to the manager. But then the manager checked that Target did send the email about the baby products and just apologized for it. There was no way of understanding why exactly the algorithm did it. since it was based on purchase patterns of pregnant people. So there was not much left to do besides apologizing. And then it turns out that the teen girl was actually pregnant, but in many cases, this type of algorithm fails, as described in this blog post quote. This person says, I've always been skeptical about the accuracy of Target's algorithm, mainly because they have found me continuously pregnant since 2010-11, the last time I was actually pregnant. And this blog post was written in October 2019. And common sense would not expect someone to be pregnant for the whole time since 2010-11. But again, there is little way to know what exactly is causing this behavior. So in summary, designing for machine learning is very different from designing for rule-based systems. And for three reasons. First, machine learning is very different from human intelligence. Second, machine learning produces output that can be difficult to explain. And then third, machine learning can produce bizarre errors due to a lack of common sense. And then these limitations of machine learning tell us when we could use it and when we definitely should not use it. And here I'll bring some examples from the People AI guidebook that is available in this link below. So please check the website to see the complete list. Machine learning adds value, especially when inputs or outputs are very diverse and are likely to change over time in such a way that it would be hard for a human to picture all the possible flows to provide good deterministic rules to cover them. And this happens in the case of personalized recommendations like Netflix homepage, classification of entire classes of entities. For example, when you use the face recognition on Google Photos, or when you want to create a bot experience for a certain domain. And speaking about customer support, although there may be a finite number of issues that could be solved, it is challenging to be able to detect which problem a customer is talking about just based on their first message on the chat. Since the text input could vary a lot, this is a problem in which keyword-based rules help you up to a certain point. But after that, if you have a lot of data, it could be useful to start thinking about machine learning models. On the other hand, there are cases in which definitely we do not want to use machine learning. And these cases will usually be related to specific characteristics of machine learning. In other words, what makes machine learning unique is also what makes it inappropriate to certain scenarios. For example, it's still inside the domain of customer support. It would be very bad for the customers if they have their Nubank account closed by mistake by a system which detects intent on the chat. In cases like this, that you want to minimize costly errors for the user, or in cases where you want to maintain predictability, for example, having a certain button always in the same place, or where you want to have complete transparency, machine learning itself is probably not the best solution. So next, Matias will talk about a few best practices to design machine learning products and show some examples of features from customer support and Nubank. Please, Matias.
Thanks, Sim. So moving next, we want to ask ourselves if a good machine learning model makes a useful machine learning product. That's our question. You have good precision, high recall, high accuracy, your model doesn't overfit. Will it make a good machine learning product? Actually, not necessarily. There are other guidelines that we can follow. Actually, Microsoft listed human AI design guidelines that complement with the ones mentioned by Google. And we can group them into 4 groups. The first one, or 4 groups of guidelines. The first one has to do with mental models. And what are mental models is what the user or the person expects from an ML product, right? Like, what is it supposed to be? What are the preconceptions? How accurate should it be? The second one group has to do about understanding why the model is doing what it's modeling, or in this case, the product. It has to do about explainability and building trust. The third one has to do about giving feedback, like being able to tell the product that is not working correctly, or having control on when to use it, or the parameters. And finally, what happens when the model goes wrong? How can we handle graceful failure? What do we do with the errors? So moving forward, we want to look at some fascinating examples from customer support. And why do we say fascinating? We have a culture in Nubank about making mistakes and learning from them, and we call that fascinating. So every time someone at Nubank makes a mistake and learn, we say fascinante. So it's fascinating experience. And we have that logo to make it even more visual. So now I'm going to focus on 2 examples of our customer support, especially from our chat, that we were actually not following these guidelines. So when we give 2 examples, I could bring actually more. It's very difficult that a system abides to all of them, and maybe it shouldn't, but I would like to focus on these 2. The first one has to do about how we set expectations and how our system was working. And the second one was about how we let our model and our system learn from new data. So one thing that you should know about Nubank is that customer support is very important for our brand and for the experience of our customers. So if you could even go to our website and you'll see that we have 4 pillars, and one of them is customer support, to the point that we even call it customer excellence. We don't even call it customer support. So when we saw that some of the reasons why people contact us could be automated. So we said, okay, let's build an auto reply for some of these reasons so that it helps our customers and also our agents to not always repeat everything. Now, how does it work? Firstly, the customer contacts us and we ask the customer to write in a text what is their issue, what they're contacting us. So then it goes to our machine learning model. We wait some time for the customer to write down what they say. And the machine learning evaluates if it could answer that. What are the features? It looks at customer's context. It looks at what the person said in the message. It has some preset precisions, like it has some percent, we previously decide how precise we want to be in our answers. This is a decision that we make. And finally, it has some blocking rules. Like there are some things that we were not going to, or in some situations that we are not going to give an automatic response. Then, so depending on all these, we say, should we answer it or not? If we decide not to send an auto reply, a message, the customer gets routed directly to a human agent. In the case we do decide to auto reply, the customer should read it and consider that it's solved, that has their issue solved, or it may reply back. And if the customer replies back, it goes routed directly to an agent. We don't engage in a conversation. If the customer doesn't reply back for a certain time, we assume that the issue was solved, that it was successful and a good experience. So this seems great, it's lean, very low friction. And for long, we thought that this was like the great experience, a very lean way of adding an ML model to our customers, to our chat experience. So is it ideal? Well, actually not, because as I mentioned, there were 2 guidelines that we were not taking into account correctly. So firstly, the system was not clear on what it could do. We're not following the customer's mental models. And why not? For several reasons. So first, many automated chat experiences are very fast. We were actually putting some time to wait for the customer to read. So we're not abiding to the usual mental model of automated responses are super fast. So it wasn't clear that the customers were waiting or were receiving an automated reply. So sometimes they receive the automated reply and they don't know that actually it's a robot. We're not clear also with that. Also, we're not clear when they would get an automated reply. We're not making it super explicit about either with an icon or a distinct type of message. And finally, we didn't build a chatbot. Most customers, either they like it or not, are used to chatbots. You cannot engage into a conversation. It's just a message. So it's also not a chat assistant. It doesn't engage you in a conversation in which you ask questions, follow buttons, you're connected to APIs. So we were not matching, actually, we are not matching the right mental model of our customers. We consider this fascinating. Of course, we're working to fix this soon, but it took more time than we should have. If we had followed the guidelines, we would have realized earlier. Let's go into the next example. We're not correctly learning from our user behavior. So I mentioned that we have an assumption that the customer doesn't reply back, we consider the issue solved, but actually that doesn't mean that the issue is solved. So we're using that, that fact as an implicit feedback to retrain our model. There were many reasons why a customer could be not answering back. Many reasons, like even distracting, like me even not realizing, maybe not reading the whole text that we're sending. Many reasons, maybe got distracted and started doing something else. Also, we didn't have a proper check that this issue wasn't being solved. We had insufficient tools for data labelers. So we didn't make it so easy to someone check on those examples and those assumptions that the issue was resolved and that the model was making the right decisions. So if we go to the next picture, to the next slide, please. So here we can see that the model makes an auto reply to the chat. The chat assumes that we have a right message, and then it gets in a feedback loop in which we keep on retraining the model with right message. We don't know, like in brackets, we don't know if they're actually right. What is the first thing that we're doing to fix this, to break this loop, is to add a customer evaluation button. So was this right? Yes, no. So by the way, there could be many ways why the message is not right. So this is not a silver bullet. So one easy one is the model didn't get it right. The model is making a mistake. Second one, maybe the customer didn't like the answer. It's saying no because of frustration, because maybe it's not getting I want my credit limit increased. For some reason we cannot give it. And the customer says, no, it's not right, but it was the right intent prediction. And third, the intent prediction of the model could be right, but the message could be incomplete or could be updated. So that's why we need these two bottom layers that are having an agent feedback, the agents who later catch the wrong answers, classify if they were right or wrong, and also quality experts who actually focus on what is a no, and they're expert in knowing what is the right way of solving each customer's problem, right? So that would be the best way of feedback, but it cannot be done in a massive way. So that's why I say that we should build better data labeler tools. And this was also a fascinating example. So moving forward, what are the principles? We have to give 3 principles for building machine learning products that is not the same as building a machine learning model. Is first, ask yourself, could this customer need be solved without an ML? So not think about the predicting problem. Don't think about what the model can do. Think about what actually you're solving. Second, you should, if you decided you do need a model, try to involve the data science team since the beginning of the product development cycle. There was a question about if we're using design sprints or not. Well, if actually we sort of do, and we involve the machine learning engineers and the data scientists right from the beginning, right? So if you're going to use a model, let everyone be there at the first moment. And finally, something very easy to do, it's at the hand of everyone, is be mindful of human AI interaction guidelines. They are free to use. Just use them as a sanity check. You don't need to abide to every one of them, but at least take a look at them and ask if your product is actually following these guidelines. So thank you all for listening, and we're open to questions.
Great. Thank you, Matias. Thank you, Cinthia, for the talk. Let's see what we have here in questions. So Nubank is very well known for its customer support, but how much does it really impact current NPS? And did you guys see any change over time since Nubank was founded?
How much does it affect our NPS? we haven't done an experiment because you may know that NPS and customer support is endogenous. Like if you get into a customer support experience, it's maybe that you may have a good or bad NPS, but maybe not because of your experience, but because of your previous problem, right? So you may get into customer support asking for, again, I get the example of credit limit increase, then maybe your NPS is related to you not getting to our credit limit increase model and not to the customer support. So the short answer is no, we don't know the impact, but we do know the impact of how good of some variables of customer support, like for example, the time you need to the first response time or a first contact resolution, or if you were attended by one or more customers, and if it has an impact with other business variables, like how much you use our product, how much you recommend our product. And the answer is, yeah, there is an impact. And actually, every time we do an experiment in customer support, we look at those variables as sanity checks. Like we don't only look at customer support metrics, we look at longer term metrics. So customer support, in a soft way, you would say, of course, customer support is valuable, but we actually know that it has an impact in the business. The short answer is, yes, it has changed, but it has changed because for two big reasons. Because we have different type of products and different types of customers. So since there were many changes in mix, there were changes in NPS. It has always remained high. It's actually one of the main metrics that we follow and we aim to improve. But yes, it has changed. And maybe the biggest drivers were those two reasons, like changes in mix in customers and products, customer base and product.
So we have a question here about the balance between predictability and the costs of the model, the engineering cost of the model. Do you have any thoughts on that? And is there any standard you guys could share?
I'm not aware of any standards for this. I'm not sure, like if we try to search it, maybe like they have like some metric that is like the ratio of the predictability and engineering cost. But I would say like we investigate it like case by case. So we usually want to, and I think it also depends on what type of model like you're deploying. If it has to be real time, or if it's a batch model that you can run, like that you would run not so frequently. So I'll leave it at that. I don't know if Matias wants to complement.
Yeah, I like the question because you're talking about the cost of the model. Like models aren't, at the end of the day, models are not so expensive. Like there's an implicit cost in everything that Leonardo talked about with the data sets and so on. And serving, of course, serving has a cost. But I would say that the trade-offs that we usually do are not, at least in customer support, that is the area that I more know, is how expensive would it be to build a product with this model? So usually the model is not the most complex part, the most costly part. It's like, okay, we can do this prediction. How can we embed it in the rest of the product? And that's, in my opinion, the costlier part where engineering has to be more involved, because you on top, maybe you have a model that has predictions, but then you have policies on top of them, and you have to reflect the output of the model in the UI and so on. And then you get a new input from the customer and you need to add that to a model. So usually what we do is we do a baseline model, we see what would be the impact, and then knowing what would be the business impact, we decide if we should do the last mile, which actually is the longest one. We would build it inside the model, inside the product, embed it to the product. If we have a rule, we don't have a rule. If that goes into the product management prioritization process, each team has its own, and each team has its own trade-offs.
So we have time for one more question, and the one we're bringing here is, how can you develop an ML product when the product, being like a new product, has no historical data that you could use?
Matias, do you want to talk about it? I feel like like one of the answers could be what you just shared about like building this first model, baseline model.
Probably you should try to do a simple rule, a heuristic that will help you learn for when you build a model, right? Or someone says reinforcement learning. Yeah, but if you do a product, probably you will not be able to interact, to experiment much like with customers. Like imagine a customer support with reinforcement learning, a chatbot saying anything would be a catastrophe, right? So you could do that with robots, with cars, very laboratory environments or games. But if you do a different kind of product, what I would say is try to build the mechanisms for learning so that you can. So I will tell you an example of how we built, very shortly, how we built our first, I say we, but I didn't do it. Someone else did it before I joined Nubank. How at Nubank, someone built our first auto-reply model. Like our agents use shortcuts, and those shortcuts have an ID. So when someone comes and asks a question that has been asked many times, instead of typing the whole answer, they use the shortcut. So that's how we got labeled the customer context and their question with the right intent, with the right answer. And that answer was made was identified by the shortcut or labeled by the shortcut. We call that macros internally. So that's the way how for long our agents had been training a model. And then we had a very rich data set. But how would you do if you had no data? I don't know, I would just spend a lot of time thinking about it.
Awesome. Thanks, Matias. Thanks, Cinthia.